In this video, I'll show you how to solve the problem called using KSP to calculate the solubility of a compound. For this problem, you'll be given an ionic compound and asked to calculate the solubility in units of grams per liter. You will need to look up the KSP value for the compound. That's going to be located over here in the ALEKS data tab. Just click on that and look for, in this case, for SrCO3. The KSP value for this particular compound is 5.6 times 10 to the negative 10. The easiest way, in my opinion, to solve these problems is to write up an ice table. We want to first write an equation for the dissociation of the ionic compound. Strontium carbonate dissociates into strontium 2+ ions and carbonate anions. We don't know how much strontium we have. We do know that we have 0 products initially. The change for this reaction is going to be minus x plus x plus x. And the minus x right here, that is the amount of strontium carbonate that's actually dissociating or dissolving. This x is our molar solubility. Not solubility, but molar solubility. So at equilibrium, we still are not going to know how much strontium carbonate we have. We'll have X strontium, we'll have X carbonate. You do need to be really careful in these problems because occasionally you're going to have a stoichiometric coefficient in these problems, and if you do, you need to make sure that you're carrying that stoichiometric coefficient down into the ice table. So we need to start by solving for X because that will give us the molar solubility, which we can then convert into the solubility. To solve for X, we're going to write an equilibrium expression. KSP is going to be the strontium ions times the carbonate ion. And again, be careful if you have a stoichiometric coefficient, like if this is a 2, this will be a 2x, this will be a 2x, and you're going to be raising this to the power of 2. The KSP value for this compound is 5.6 times 10 to the minus 10, and that is equal to x squared. So let's solve for x. Square root of 5.6 times 10 to the negative 10. That is 2.37 times 10 to the negative 5. And again, this is the molar solubility. So this is the moles of our compound, SrCO3, divided by liters. To get this into solubility, we just need to do a mole to gram conversion. So we're going to use the molecular weight of SrCO3, which is 148 grams per mole. And you can see here that our mole units are going to cancel. We're going to be left in units of grams per liter, which is perfect. When you're doing these problems, just make sure that you're using ALEKS's calculator so that you can get a really accurate molecular weight. To keep ALEKS happy, 0.0035 grams per liter.